All right, so we are going to be continuing to talk about, for the test and the review, we're starting on question number 13. So again, question number 13, we're still dealing with point slope form y minus y1 equals m times x minus x1, where the x1, y1 is a specific point. So looking at these problems, we're looking at taking out the point of x1, y1. Now your slope on all four of these is the same. We don't change anything. And again, our slope is, not negative. Our slope is going to be next to the x. Okay, that's right here in front, or next to the, in front of the parentheses, in front of x. So that is our slope. Now, looking at our x value and looking at the point, so looking at our point in terms of this, our x value is going to be on the same, our y value is going to be on the same side of the other y in terms of our y1. So looking at our y1, it's going to be opposite when we put it in the point. So that's, since that's positive 2, it becomes negative 2. This 4 is our x1. Again, it's going to be opposite when we take it out. This negative 8 for our y1 is going to be opposite. Since it's negative, it becomes positive. Same with our x1 here. Our x1 is going to be negative 1 since it's positive 1. Our 5 for the y1 is going to be negative 5. For the x1, it's going to also be negative 7. Both of these are going to switch, so that becomes positive 8 and positive 3. Pretty straightforward and simple. Now, 14 through 18, to recall, we're talking about where we have direct variation. Y varies directly with x. And what that means is when we're talking about that, we have the equation y equals kx. Your k value is equal to y divided by x. So looking at our y values, okay, y varies directly with x. So we've got 16, and then our x value, okay, divide x. So this is going to become k is equal to 16 divided by 8, because that's all we got to do. We don't have to think about the change. That's going to give me 2. So now writing an equation, just like we did y is equal to kx, that's going to become y is equal to 2x. All right, now let's answer the question that it's asking us to answer. It's asking us, it gives us x is equal to 16. It wants us to find the y value. We don't know what the y value is when x is equal to 16. So think y is going to be equal to 2 times our x value of 16. So that's going to give me y is equal to 16 times 2 is going to give me 32. It's that straightforward and simple. So looking at 15, that's going to be 21 divided by 3. So k is going to be equal to 7. So our equation is going to be y equals to 7x. We're looking for x now, and we're given the y. So 42 is going to be equal to 7x. Then we got to solve for x. So 42 divided by 7 is going to give me 6. So x is equal to 6. So do pay attention to when we get to this part of the equation of whether or not we're looking for the x value or the y value. Because if you're looking for the x value, you're going to need to divide by the k value. All right, number 16, we have A varies directly with B. So that means our k is going to be equal to A over B. So now our equation is going to be A is equal to KB. So now 21 divided by 6 is going to give us our k value. Now that simplifies to 7 over 2. So now that's going to give me an equation of y is equal to, not y, because we have different variables. That's going to give me A is equal to 7/2 B. Now, our B value is 4.2, so our A is going to be equal to 7/2 times 4.2. When I put that into my calculator, that's going to give me A is equal to 14.7. All right, on number 17, we're looking at 12 corn muffins for 1 cup of flours. So that is going to be 12 divided by 1. So our equation is going to be y equals 12x. Okay, now the number of muffins, okay, 12 corn muffins, varies directly with the amount of flour. So we're going to have corn muffins be y, the amount of flours be x. We want to make 54. So that is the y equals 54. So I need to take 54 and divide that by 12. So 54 divided by 12 is going to give me 4.5. So x is going to be equal to 4.5. So that is 4.5 cups of flours. All right, number 18, you're doing the same situation. So we have the grade on your test is directly proportional with the number of problems that you get correctly. So we're going to have the number of problems be x and the grade on your test be y. We have 40 problems, so 40 problems is x, and we make an 80, the grade on the test, which is y. So k is going to be 80 divided by 40. So that gives me 2. Now, you get 40 problems, that's x, correct. So to find the y value, the grade on our test, we're going to do 2 times 43, which is going to give me an 86. So if you get 43 problems correctly, then we're going to score an 86 on the test. All right, we're on a new topic now. We're looking at the slope and y-intercept and the equation. All right, so to remind ourselves, looking at this, our slope is rise over run. I'm going to find my y-intercept first. My y-intercept is where we're on the y-axis, to remind ourselves. That's our y-intercept. That is the point there at -6. That is when x is equal to 0. Okay, rise over run. I'm going to find 2 nice points. I got the y-intercept and I got this point right there. We're going to rise, so we want to do the vertical change first. So that's a rise of 1 and a run of 3. So our slope is going to be 1/3. So now we know our y-intercept and our slope, so we can write the equation in slope-intercept form. So that's y equals 1/3, don't forget your x, and then -6. We want the slope of a line that is parallel, so that means same slope to the line graph. So that is a slope of 1/3. Perpendicular, we want to flip and switch the slope. So that means since this is positive, we now need it to become negative, so that's going to be -3. Now we're going to write the equation and graph our line that is parallel. So if I have the point 6, 3, okay, parallel means same slope. So normally our slope is 1/3, so that's a rise of 1 and a run of 3. So if I go up 1, write 3, I've at least got 2 points graphed, but I need to find my y-intercept to talk about my slope being parallel and writing the equation of that slope. So we're going to go back to that point that we initially graphed, the 6, 3, and we're going to do opposite day. So that means I'm going to go down 1, and then I'm going to go left 3, down 1, and left 3. I've now hit my y-intercept, and that is a y-intercept of +1. So I can go ahead and draw my line. So we have finished that question. We're going to go to number 20. Again, we're going to do the same thing that we just did above. So that's going to give me a y-intercept of -1. That's going to give me a slope of the graph. I'm going to pick 2 points. I've got that point there of our y-intercept. We're going down 2, and then we're going right 3. All right, we're going to write the equation. Y equals -2/3 x minus 1. Parallel is same slope, so that is -2/3. Perpendicular, we want to flip and switch, so that is +3/2. We're going to do the same thing that we did before. So I'm going to plot this 0.6 -1, that's there. And then we're going to talk about the slope. So normally I would go up 3, right 2. We're going to do opposite days. So down 3, left 2, so that I can go back to my other line, or sorry, get to my y-intercept. So I'm going to go down 3 and then left 2. Wait, hold on. I messed up somewhere. Yep, I went down 3. Wait. Down, yep, that's where I messed up. I messed up there. Okay, so down 1, 2, 3, left 2, 1, 2, 3, left 2, 1, 2, 3, left 2. I'd already had the dot on the other line when I was looking for my graph, and that kind of threw me off. I was thinking it was the same. I just drew that point. Okay, so we know our y-intercept is -10. Okay? You can set up this one the same way. So all we're doing is looking at this. So if I have the slope of the line, our y-intercept is 5. Slope is at that point and that point. That's a rise of 1, 2, 3, 4 over 2, which is a slope of 2. Oh, wait, sorry. Nope. I miscounted. It's a 1, 2, 3. It's a rise of 3, run of 2. All right. So our equation is going to be y equals 3/2 x plus 5. Parallel is same, so that's 3/2. Perpendicular is to flip and switch. So I did not switch, or I did not flip. I switched the sign but did not flip. So that is 2/3. We want parallel. So I'm going to use y equals 3/2 x. I'm going to go to 10, 9. So that's that point right there. So we're going to go backwards. So normally we would go up 3 and right 2. We're going to go down 3, left 2. So 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. And I hit my line. That is a y-intercept of -6. Boom, done. Easy peasy. All right, we're going to go to 22. So 22, we're starting to look at correlation coefficient. So to remind ourselves, we have a from -1 to 1, with 0 being in the middle. The stronger we get to this is a strong negative correlation. This is a strong positive correlation. And then the closer that we get to 0, we have no correlation with 0, and then weak once we get past a half, closer to 0. So looking at number 1, I would say that that's a weak positive. This is definitely a strong negative. This would be no correlation. This would probably be a weak negative correlation. This would be strong positive, strong positive. I would also say that this one is strong negative versus weak, because if you compare saying this one here and this one there, I would say that this one is stronger than this one here in terms of being closer to 1/2. This is probably maybe 0.8 or 0.85 or something like that. So that's still a pretty strong correlation. All right. Number 23, all you're doing is if you take a line and let's see, can I get a ruler on here? Nope, I can't get a ruler on here. If I draw a trend line, okay, that's pretty much, we sketched the trend of the graph. So now all I got to look at where x is 15, that's here, and then I'm going to look at where it crosses the graph. It's crossing the graph at approximately 9 to 10. Depending on your answer choices, you'll be able to pick the correct answer. And then we're looking at 32. So 32 is going to be between 5 to 6. It's probably closer to 5 than it is to 6. Same with the 9 to 10. But we're just doing a quick ballpark figure. And you're going to have multiple choice if you have a question like that on the test. Same with number 24. So we're just drawing a general trend line that looks pretty good. We want to go 20 degrees. So 20 degrees is our x-axis. So 20 degrees is right there. That's right about $400. And then 13, we're at about $200. So we're not nearly making as much money in terms of ice cream sales when it's colder. And that makes sense. We've sketched the trend line on the graph. Now, the next problem, we have a little bit more accuracy that we can do and rely on in terms of our scatter plot. So we're going to go ahead and bring up Desmos. And I'm going to make sure that my graph is on both of these screens so that that can help me put the table. Now, just to mention this, you are only going to be putting these values on the table. You don't want to put that 80 on the table because that's what we're looking for when x is equal to 80. So I'm going to go here and I'm going to add table and I'm going to list those values. So 92, 75, 50, 20, and then I'm going to go up and add the y values. So 95, 73, 67, 45. All right, once we've added our values into the table, we're going to click this box right there, add regression. And this is a linear line, so if you look at zooming in, this looks like pretty much a straight line in terms of our graph, and it's already giving you your trend line, which is what we really wanted. Now, looking at our data value, there's a couple ways that we can go at this point, all right? First of all, we're going to write our equation. I think I miswrote something here. Hold on, let me double check my tape. 92, 75. Oh, I forgot the 65. I am off on my table. Here we go. 95, 73, 67, and 45. And that one is 40. There we go. All right. Now my table looks good. All right, so we're going to write our B value. To remind yourselves, your B value is the plus, so that's 17.44. Your slope is the coefficient with x, that is 0.77. And now, a couple things here, a side comment. If you're asked for the correlation coefficient, you're looking at this R value right here. Come on, highlight it. It's not highlighted. There. You're not this value. We don't care about that value there. We care about this value. That is a very strong, 0.94 is a very strong positive correlation. All right. Now, real easy here. I'm going to make our life super easy. So we want the estimate between a grade of 80. So the homework grade is X. So X is equal to 80. So I'm going to write an equation, X is equal to 80. And that's going to give me a horizontal or vertical line. And I'm going to click at where those two lines intersect. So here's the X is equal to 80. Then I'm looking at this value here, 79. If I'm making a homework grade of 80, that means on my test grade, I'm probably going to make a 79. You're going to do the same thing with the next question. The next question is saying a homework grade of 100. So I'm going to change this 80 to 100. I'm going to look at that point. So if I'm making 100 on the homework grade, I'm probably going to make a 94.5 or a 95 on the test. Now, it also wants us to find when this is 0, so I can still do x is equal to 0. And we should know that that's going to be our y-intercept. And that is a y-intercept. To remind ourselves, we already know what that y-intercept is. We entered it up above when x is equal to 0. That's going to give me 17.44, which we already estimated. Let's see. They pretty much answers that question. Now we're going to go down here to this section and we're going to look at increase, decrease, or stay the same. We're basically creating just a general trend line between these graphs and these data points. So if I look at this first one, I need to decrease my slope and I need to decrease my y-intercept because I want this one to come down and become that one. I need to make this graph look more like that, even further, more like that, right? So we need a decrease. This one, our slope is going to stay the same, but we need to shift